1, so 2 would work, and one more.
3.
Yeah. Okay, that's great. So now we need to find the corresponding y values. So we want to sub these x values into the function that corresponds with that particular domain. So Aaron, can you do these for this function since it matches with that particular domain?
It's frozen, so I don't really know which one you're talking about.
Oops, I'm sorry. So the blue table, will you put those x values into the first function for me and tell me what the corresponding y values are? It is very jumpy and frozen. I'm sorry.
You want me to do what?
Take the x values from our blue table
Uh-huh.
and put them into the function that corresponds with our blue domain.
Mm-hmm.
Get these y values.
Oh, okay.
Yeah.
Mm. The first one is going to be 3.
Mm-hmm.
The second one is going to be 1.
Mm-hmm.
And the last one is going to be -1.
Perfect. Does anybody have questions about how Aaron solved each of those? Because we didn't write it out.
Yeah, I'm a little confused.
Okay, so I'll write them out down here. We took each of these x values, we subbed them into this function. So we said 2 times 1 plus 1 equals 3. 2 times 0 plus 1 equals 1. And 2 times -1 plus 1 equals -1. So that's where like these numbers came from. Does that make sense?
Yes.
Okay, perfect. And we picked this function because it corresponded with the blue domain, which was what this table was for. Okay, good. And then Brandy, will you help me fill in the table for function?
Yeah. 1.
Yeah.
-1.
Yep.
And then -3.
Yep. So here, I'll write these out as well. So this is -2 times 1 plus 3. That's going to give me 1. -2 times 2 plus 3 is going to give me the -1. And -2 times 3 gives me -6. And when I add 3 to that, I get a -3 as my total. Okay, so those numbers then filled in for my y values up here. Good job, guys. So now we want to plot them. And since it's kind of difficult for somebody to like aid in plotting, I'm just going to go ahead and do them. So our blue graph had a point at 1, 1, 2, 3, and it was an open circle. Then we had a point at 0, 1, and we had a point at -1, -1. Oops, I made it a little bit too far down, but okay. And then these were values less than 1. So we want our arrow to be moving to the left, and we see that our points kind of force it to move down. So this was the blue section of our graph. What questions do you guys have about that particular part of the graph?
The point at 1, 3 is open?
Yes.
Okay.
Yeah, so this is an open circle. Then for the green, we have a close point at 1, 1. So I'm going to put like a big closed dot right there to show that that part is there. Then we have a point at 2, -1 here, and a point at 3, -3. So here. And that is our green function. Okay, so questions on that green function. Okay, so we've evaluated points and we've graphed it. And that's pretty much it for our warm up. Any last questions before we move on? Okay, so there should be a little sheet that is uploaded on Canvas. Let me make this bigger. It looks kind of like this. It's like a half sheet, and it used to be a homework assignment. I'm going to use it just to remediate piecewise functions for today because I feel like you guys need that, or at least the other classes did. You guys are kind of killing it. But I'll let you guys pick which one you want to do, number 1 or number 2. In my second period B day, we only did one of them. For some reason, in my math 3, I think because they just don't ask questions, we got through both of them. So we'll just see what we get through today. And if you guys have questions, we can slow down or speed up accordingly. So I'm going to put the whole thing in the screen. Which of these two problems looks more challenging to you guys?
Probably the second one.
Okay. So I have 1 vote for the second one. Does anybody agree or disagree?
I agree.
I agree.
Okay. All right. Sounds like we are going to do the second one, which is awesome. All right. I think that's good. All right. So we have 2 sections here. And so it asks us to graphify functions and find these values. Which one do you want to do first? Find the values or graph?
Find the values.
Okay, so we'll find the values. So let's see, Tanaya, you're next. Can you get one of these? Which one do you want to do?
Probably the first.
What'd you say?
The first one.
Okay, perfect. So is 1 going to be between 0 and 4 or bigger than 4?
Between 0 and 4.
Perfect. And so we're going to sub it into this function. So we're going to have 4 times the square root of 1. And the square root of 1 is just 1. So this is 4 times 1. And what did we get as our final answer?
4.
Perfect. Okay. Brandy, can you pick one of the other 2?
The F4.
Okay, perfect. So is that one going to be between 0 and 4 or bigger than or equal to 4?
Bigger than or equal to.
Perfect. So I'm going to have -2. So I'm going to choose this function times the absolute value of 4 minus 4 plus 4. So Brandy, what's 4 minus 4?
0.
Yeah, so this is just 0, and the absolute value of 0 is just 0, so there's not much we can do with that. We're adding 4. The -2 times 0 is 0 plus 4. So our final answer is what?
4.
Yeah, sorry. All right, perfect. All right, and then Francesca, can you do f of -1 for me?
It's going to be in between 0 and 4.
Are you sure?
Wait.
Is -1 bigger than 0?
No.
No. So it can't be in the first one. Can it be in the second one? Is it bigger than or equal to 4?
No.
No. So this point just does not exist. Okay. So it's a trick question. There are no solutions. What questions do you guys have on that?
Wait, why is there no solution?
Good question. So -1 is not between 0 and 4. It's also not bigger than -4. If I drew out a number line, and then, so we have from 0 to 4, -1 is right here. 0 to 4, so I'm going to highlight my two domains. Zero to 4, the blue part, is going to have a closed circle on 0, an open circle on 4, and it's going to be all this stuff in between. So it's this. And then the green part has a closed circle at 4 and then goes all the way to infinity. This green part is that stuff. Okay, but -1 is not in the blue or the green section and never will be. Does that help?
Got it.
Okay, perfect. Yeah, I feel like the number line helps out a little bit when you're looking at the domains. Okay, so now what if I gave you evaluate 2 times f of 3 minus 3 times f of 1 plus f of 0. If I gave you something like that, would you guys know what to do?
This was like the home, right?
Yeah. Do you guys have trouble with it?
Struggling. Not gonna lie.
Yeah.
You'd have to distribute the see, I can't.
So like f of 3 is one of these guys, right? It's like it's a number. We got to figure out what each of these numbers actually are and stick them in there. So we would have 2 first. Now we need to figure out what number is f of 3. So is 3 going to be in the blue or the green section?
The blue.
Yeah, the blue. So it's going to be 4 times the root of 3. So 4 square root of 3. What questions do you have about that? You guys see how and why I did that?
Yeah.
Okay. Any questions at all about that?
Are we solving the evaluation right now?
Yeah, we are, sorry.
Okay.
Okay, so we've replaced the f of 3. Now we have minus and a 3. And now we need to figure out what f of 1 is, but we already did that. We found f of 1 was 4, so we can just replace f of 1 with 4. Then we're adding on f of 0. Oops, I should not have written that. Save it. Okay, so we got to figure out what f of 0 is. So is 0 going to be in the blue or the green section?
The blue.
Yeah, the blue. So if I stick 0 into here, what do I get?
0.
0?
Yeah, 0. Good. So I'm going to have plus 0. Now I've got to simplify all this. Okay. So 2 times 4 times the square root of 3 is just going to give me 8 root 3. And then 3 times 4 is 12. I'm going to subtract 12. And because this one has a square root in it, and this one does not, we can't combine them. This would be our final answer.